Okay, so we are going to go over ion formation and dot notation for elements on the periodic table. So you want to have this graphic organizer open, and I'm going to walk through its important vocabulary and just kind of talking through how ions get formed. So a valence electron is an electron in the highest energy level, and it's an electron available for chemical bonding. An octet is a group of 8 valence electrons. And that's what everybody's trying to get, so that they really want that noble gas configuration. And so valence electrons are equal to that of a noble gas. Remember that that's group 18 or 8A on your periodic table. And a noble gas, so for most elements, a noble gas configuration is an octet. All right, is those 8 electrons. But there's a few small elements like hydrogen, lithium, beryllium, boron, and they are going to have the configuration of helium, which I don't need that 1s2, but that's a duet. And that's because the first energy level only holds 2 electrons. So when atoms form an ion, okay, they can either be a cation, and that is a positively charged ion, and it typically forms when a metal loses electrons, and an anion is a negatively charged ion, and it forms when a nonmetal gains electrons. So this is the graphic organizer down below. I have it split in half so that I can kind of show you my work as I go. So we'll do both halves here in theory. Get this to scroll back up a little bit. So above the graphic organizer, you have metals lose electrons. And they form cations. And normally when students think of this, they think, oh, losing is going to be negative, but you're losing an electron. So it's subtracting a negative, which means you're going to be more positive. All right. So that vocab is important because an electron is negatively charged. So let's take a look here at the metal portion of our periodic table. So group 1. Everything in group 1 has 1 valence electron. And everything in group 1, hold on one sec, is going to have that 1 dot notation. So you have sodium with 1 valence electron, and everything wants to be like the nearest noble gas. So sodium really wants to just get rid of that 1 valence electron. And if we just look at a neutral atom of sodium, okay, so sodium is number 11 on your periodic table. It has 11 protons, 11 electrons, but it's really, really close to neon, which is number 10. And neon has a filled outer shell with the first and second energy level filled. And so for sodium to be like neon, it would have to lose an electron. Well, it's not going to lose the number of protons, so it's still going to have 11 protons, but now it's going to have 10 electrons. And so the charge on an ion is a comparison between how many protons versus how many electrons there are. And there's 1 more positive than there is negative since we lost a negative. And so the ion that's going to be formed is we're going to write sodium, and then we're going to write 1 positive. So the symbol, and then how positive it is. So that's everything in group 1. So we're talking all of the elements in group 1, so hydrogen, lithium, sodium, potassium, rubidium, so on. All right, group 2, everybody has 2 valence electrons, and magnesium in all of them will have the 2 dots. they will lose their 2 electrons because it's easier to lose 2 than to gain 6 because everybody wants to get to that octet. So it's easier to lose the 2 than there would be to gain 6. And so you'd have the symbol of magnesium, and then you write 2 positive. Group 13, I could have put boron here. I put aluminum. And everybody in this one has 3 valence. So aluminum has the dot diagram 1, 2, 3. And it's easier to lose 3 than to gain 5. And so aluminum's the iconic metal in that group, or gallium. And so it's going to be 3 positive there. Now, group 14 is what I would call the weird group. And you can maybe label that above. But they have 4 valence electrons, all right? And so, you know, the dot diagram, they're all going to have 1, 2, 3, 4. But, right, like, are they going to gain 4 or lose 4? So most of the time, so your non-metals in this group, which are going to be carbon and silicon, because then you get into germanium is also, it's a metalloid, and silicon is too, but carbon and silicon really do act like non-metals here. They don't actually lose electrons. They're going to do something that we'll learn about a little bit later, is they're going to share electrons. Rewrite share electrons, and they're going to form what's called covalent bonds. But if you look down group 14 or 4A, you do have some metals, tin and lead. And metals, we talked about, lose electrons. So the metals, tin and lead, those are the symbols for tin and lead here. They will lose 4, and so you will get a 4 positive on those 2 elements. So that's what your metals do. And then I'm going to scroll down to fill out the second half of this graphic organizer for us. So hopefully you have everything there. So then we get into our non-metal area of the periodic table, groups 15 through 18. And non-metals will gain electrons because they're closer to having a full outer shell, and they form anions. And again, normally when students think, oh, gaining, they think more positive. Anions are negative because you're adding a negative. So if you're adding more negative, it's going to make overall the atom now an ion that's negatively charged. So if we look at this, we have group 15, phosphorus being the representative element. Again, any of these could be any of the elements in group 15 because all of the elements in the same group have the same number of valence electrons. So everybody has 5. The dot notation for phosphorus or any of these, you're gonna have 1, 2, 3, 4, 5 dots. Now it's easier to gain 3, okay? Fill in 3 here, all right? I'm gonna undo that just so it's not left with those dots here. Maybe. And one more. Okay. Oh, okay. I thought I was going to lose more than I thought. So, okay, phosphorus 1, 2, 3, 4, 5. It's easier to gain 3 than it is to lose 5, and so it's going to form the phosphorus 3 negative. And if we just kind of work it out over here, so a neutral atom of phosphorus, okay, has 15 protons, 15 electrons, but it's really close to argon, which is number 18 on your periodic table, and argon is a noble gas that has a full energy level, and so it would have to gain 3. So we're adding 3 electrons. We're not changing how many protons there are. So we still have 15 protons because that's what makes phosphorus phosphorus, but now we have 18 electrons. Well, what do we have more of? We have more electrons. How many more? 3. And that's where you get the charge here, okay? So the overall charge on phosphorus is going to be 3 negative. Group 16, everybody's going to have 6. And the dot diagram, you're going to have 1, 2, 3, 4, 5, 6. And getting closer to 8, it's easier to gain 2 than to lose 6. And so everything in group 16 is going to form that 2 negative. Then you've got group 17 with 7 valence electrons. And we've got chlorine as our representative element. So 1, 2, 3, 4, 5, 6, 7. And really, really, really close to 8. And so they all really want to gain that 1 electron and then form that 1 negative ion there. And group 18, this is going to be everything except helium, all right? So helium would not be included in this, but they all have 8, all right? So except helium. And you could make a little note somewhere on your little table that helium is just going to have 2, okay? So not 8, but just 2. Now, they already have filled energy levels, so they really have no desire to do anything fun or exciting. So I call them the no fun group in terms of chemical bonding because they form no ions. They really don't. They do no bonding, no chemical bonding. They are no fun. They would be the no fun people at the party or the hangout, the barbecue, the picnic, because they don't want to do anything. They're too cool for everyone else. So they're no fun. So yeah, so let's just look at what this looks like on the periodic table real quick. So we did representative elements from each group, but if you want to kind of mark on your periodic table, not only do we have like our valence electrons, so group 1 has 1 valence electron, but everybody in that group wants to lose their 1 valence electron, and so they're all going to be 1 positive ions, okay? And so let's go mark our valence electrons. So we've got 2 valence electrons here. We're going to skip this region. We're not going to do ions for this, okay? Those are transition metals. They do weird things. We'll cover that in a later course. And then we've got 3 valence electrons, 4, 5, 6, 7. You've got 2 right here, but then all of these have 8 valence electrons, all your noble gases. So if we go back, so if you have 1 valence electron, it's easier to lose 1 and go back to the previous energy level from that 1 positive ion. If you have 2 valence, you're going to lose 2 and form a 2 positive ion. If you're in group 13 or 3, you have 3 valence electrons, and so you're going to form a 3 positive ion. Now, group 14, we talked about, doesn't really form ions, at least not carbon or silicon. Maybe germanium does, but what we do want to note is on here is that tin and lead, they are going to form 4 positive if they are going to form an ion because they're metals, and metals want to lose those electrons. So group 14 kind of has a variety of stuff that it can do, but then so don't mark it as like, you know, one thing. But now you get to group 15, nitrogen, and these all have 5 valence electrons, and it's easier to gain 1, 2, 3, so 3 negative, and then group 16 is going to be 2 negative, and then group 17, 1 negative. So hopefully you can see the pattern. It goes +1, +2, +3, skip, 3 negative, 2 negative, 1 negative, and then no ions here, okay? They already have filled energy levels. So I hope this is useful and in helping you determine what ion is formed and how that fits into the other organizational structures that we have with the periodic table. So that's it for this video. See you on the next one.